Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 3.1, which is going to deal with sequences of transformations. So 3.1 is our start of Module 3, which is going to build off of Module 2, where we talk about translations, rotations, and reflections. So we're going to carry those three different types of transformations and how to use coordinate notation into our lesson for today. All right, section 3.1 on sequences of transformations. Before, up to this point, we've always done one transformation at a time. We just translated a shape, so we slid the shape to one spot, left or right, up or down. We either reflected the shape or we rotated it given the situation. Today we are going to add in a sequence where that means there's going to be multiple different transformations occurring. So, before we jump into our first example, our learning goal for today is you will be able to draw the image of a shape after a given sequence of transformations. So a sequence could involve two different transformations, 3 or 4, whatever they ask you for each situation. Now, example 1 is going to have us go through and draw the image of the figure in the plane after the given combination of transformations. So we're going to go through and draw our transformations for today based off the sequence they give us. So example 1, part A, I'm going to move this up more so it's a little easier, more space. Okay, example 1, part A, we're going to go through and draw the image after the given combination of transformations. So our sequence is xy goes to 3x comma y, which goes to 1/2 x comma negative 1/2 y. So we're going to apply this sequence to our shape in the coordinate plane, and we're going to draw our final image. Now, I've already gone through and identified our points A, B, and C based off the graph. The original point, A, is at 0, -2. B is at -2, -4, and C is at -4, -4. So these are original points, are x, y, and that is going to be our starting point for this problem. Now, we already have our first set, so next we need to apply the 3x comma y. So we're going to go through and figure out our quote-unquote prime locations. So A prime, B prime, and then C prime. So our rule for this one is 3x comma y. That means I need to multiply all the x values by 3, and then all the y values stay the same. So what I'm going to go through and do first is multiply all the x values by 3. So for A, we have 3 times 0, which is 0. We do 3 times a -2 for B. B prime is going to be at -6. And then 3 times -4 is going to give us -12 for C prime. All right, all the y values, because it's just y, all the y values stay the same. So -2, -4, -4 for A prime, B prime, C prime. All right, normally when we went through and did transformations in Module 2, that would be our ending point. We would go through and plot the points and we are good. Now, you can go through and plot the points now if you would like, or you can wait till the end. Or we can go through and find our other set of points because we've done one sequence. We now have to complete our other sequence or our other transformation, which is 1/2 x comma -1/2 y. So the way I'm going to think about this is you can either multiply by a half to all the x values, or because it's 1/2, means we could go through and divide all the x values by 2. So because we have another sequence, instead of just being A prime, this becomes a double prime, so 2 primes, B double prime, and then C double prime. All right, so because it is 1/2, okay, we're going to multiply all these numbers by 1/2. So, or you can divide them by 2. So if we go through and do this, what we're going to do is we're going to multiply all the x values by 1/2. So we are going to do 0 times 0.5. We get 0. We're going to have -6 times 1/2. And we get -3. And then -12 times 1/2 is -6. So that means we have 0, -3, and then -6 for A double prime, B double prime, C double prime. All right, for the y values, it's -1/2 y. So it means I need to multiply a -1/2 to -2, -4, and -4. So if I do -2 times a -1/2, we end up with 1. And if I do a -4 times by -1/2, we end up with 2 as our answer. So that means A double prime is at 0, 1. B double prime is at -3, 2. And C double prime is at -6, 2. And then that is our second transformation. Something I forgot to mention before I kind of continue with this problem. Okay, I take my original set of points, I plug it into this sequence, and I get my new set. For the third set, you do not go back to these original points and plug them in, yet you take your new points and you plug them into the new transformation. Okay, so don't go back to the original, you go back to your most recent transformation. Alright, so now that I have all set of my points, I've completed all the transformations, you're just going to go through and graph each of these. Now, to kind of save time in graphing and drawing lines and whatnot, I am just going to put my completed notes up, so that way I can talk about it. Instead of purple, it's a light blue for the primes, and the red is double prime for the reds. Alright, so, example 1. Okay, I have all my original points, A, B, C, A prime, B prime, C prime. That is this light blue triangle here. There's all those points graphed. And then A double prime, B double prime, C double prime is this graph right here. So this is my image, this is my final spot for my transformation after the sequence of transformations. So this is my final resting place, and that is how you do example 1A. And the same thing is going to be the case for parts B, C, and D. It just includes different types of transformations. So let's move on. Parts B and C. All right. So we are going to continue the same idea where we're going to take the shape that they give us in the coordinate plane. So triangle ABC is at 2, 2, 2, 5, 3, 2. And then we're going to place it into our different rules for transformation, find our new points, and then go through and graph. And the same thing for C. So let's take a look at B first. And I'll place my calculator over here in case we need it. All right, for B, we start out with x comma y. And for x comma y, it's going to go to x minus 1 comma y minus 1. So our primes, see if I can draw a little arrow to distinguish. So A prime, B prime, C prime. Okay, we're going to subtract 1 from the x and subtract 1 from the y's. So that means we're going to do 2 minus 1, 2 minus 1, 3 minus 1, and then 2 minus 1, 5 minus 1, and 2 minus 1. So that means A prime, 2 minus 2 is 1. So it's at 1 comma 1. B prime, It's 2 minus 1 is 1, and 5 minus 1 is 4. So it's going to be 1, comma, 4. And then C, 3 minus 1 is 2, and 2 minus 1 is 1. So that is my A prime, B prime, and C prime. Next, my second one is going to be 3x comma y. So that means we're going to multiply all the x values by 3, and all the y values stay the same. So A double prime, B double prime, and then C double prime. So x values, because it's 3x, that means we're going to multiply all these by 3. So we're going to get 3, 3, and 6, because 3 times 1 is 3, 3 times 2 is 6. And then all the y values stay the same. So it's 1, 4, and then 1. All right, and then my last transformation, so we're going to be at triple prime, so A triple prime, B triple prime, and then C triple prime. What we're going to do for these, so it's negative x comma negative y. That doesn't mean that all of them have to be negatives. Again, remember the negatives imply you change the sign. So positive to negative, negative to positive. Okay, it just so happens to be that these are all positive, so they're all going to switch to negatives. But just because I'm doing that doesn't mean all the numbers have to be negative in every situation. So this becomes negative 3, negative 1, positive 3, positive 4 goes to negative 3, negative 4, and then negative 6, comma, negative 1. So I'm kind of running into my next problem. But those are my points for that one. And if we go through and graph them, again, I'm going to put up my final result. For part B, so the green triangle is going to be my first transformation. So A prime, B prime, C prime. So we moved it to the left one, down one. For my double prime, my blue triangle, we increased it horizontally by 3, and it stayed the same vertically. And then for my last transformation, my triple prime, my red triangle, we rotated this by 180 degrees. All right, so that is how you're going to run through and do part B. Now, part C, I'm going to uncover my completed notes, but I will talk about what I've done. For this, I'm not going to run through it step by step. Okay, we know our points for A, B, and C from the original triangle are 2, 1, 0, 2, 4, 3. Okay, my first rule is 3/2 x, comma, negative 2y. That means you're going to multiply all the x values, 2, 0, 4, by 3/2. The best way to do this in your calculator, okay, let's say we take 2 here. The best way to do this would be to take 2 times and then in parentheses do 3 divided by 2. And I should have typed a 2. End parenthesis and enter, and then that will give you your answer. Okay, so doing fractions, be sure to use parentheses when you do this, so that way it knows all in the right part. So we multiply 3/2 x, and we get 306. Multiply by negative 2 to all the y values. We get negative 2, negative 4, negative 6. And then our second transformation, to subtract 5 and then add 4. So we get our new values. So if we look at this, we go from our black triangle to our light blue triangle, and then we translate the shape back 5, up 4 for our red triangle. So that is how we go through and do example 1, where we apply the sequence of transformations. I really suggest that you go through and do the points first, then plot. And just remember, like I talked about with example 1a, okay, you start out with your original points. You're going to plug these, and it's kind of cute colors. Okay, you're going to start out with your original points. You're going to take these points, you're going to plug them into this transformation, and you get your new points. Once you get your new points, you do not go back to these set and plug them in here. Yet you take your new points and you plug it into your new transformation to get your new set. So you keep continuing on. You don't keep going back to the original. Okay? Don't keep going back to these set. Once you've transformed them, this is your new set that you plug in. Okay, so that is example 1 for section 3.1. We only have one more example, and example 2 is going to ask us to predict the result of applying a sequence of transformations to a given figure. So, for A, it tells us triangle LMN is translated along the vector -2, 3. It's reflected over the y-axis and then reflected across the x-axis. Now, you can do this a couple of ways. You can print these out, and you could go through and do it on paper. You could use wax paper and kind of do different stuff. You can use the different rules. Okay, I'm going to do this all just based off visual and what we know about each transformation. So at first, it tells me this triangle is translated along the vector -2, 3. That means it goes to the left 2, excuse me, and then up 3. So we go back 2, up 3. So each point is going to go back 2, up 3. So when I go back to up 3 for each point, I'm not going to be worried about the exact coordinates for this. Okay, so I would predict that that triangle would go there. So this would be kind of after my first transformation, that it would end up here. My second one is that it's reflected across the y-axis. Okay, the y-axis is right here, meaning I need to take this triangle and I need to flip it over here. So by flipping it over here, okay, this point is 1, 2, 3, and then 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And my other point is going to be here. So my reflection across the y-axis is going to be there. That's my prediction. So that's 2. And then I want to reflect this across the x-axis. So my x-axis means I need to take this triangle and reflect it down here. So I need to flip this down to here. So that is going to end up, let's see, this point's going to end up here. This point here and there. So I have my points for my triangle there. And because that is kind of my final transformation that we make, I'm going to make the prediction that this is my final resting spot of my triangle. Now, sometimes they just want you to go through and predict where it is or what's happened. Okay, something I want to remind you, in case it asks you about what quadrant will this end up in. Okay, this is my predicted result. Remember it's quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. So I predict that this is going to end up in quadrant 4. Okay, because I moved it to the left and then up, I reflected over, and I reflected down. Now, parts B and C are kind of continuing the same thing. It's just involving different shapes and different transformations. Okay, you can always take a look at my completed notes. I'm going to walk through them here just to kind of explain what I did, because sometimes seeing the picture doesn't always help as necessarily as hearing me explain what I've done, but you should be able to reference it from there. All right, for B, it talks about square HIJK is rotated 90 degrees. So I've taken this square. I went through and used the rules for transformation for 90-degree rotation, but this is clockwise, not counterclockwise. If it was counterclockwise, it would be over here. So I'm rotating it clockwise. So that's my first point. And then it talks about being dilated by a factor of 2, which maps xy to 2x comma 2y, which means I'm going to increase this by 2, and then that is my final resting spot for this square. All right, and then for C, so again, that was quadrant 4 for B. For C, rectangle GHJK is reflected across the y-axis. So we're taking this rectangle, we're flipping it over, and then it wants us to translate along the vector 5, 4. So that means we move it to the right 5 and then up 4. So each of these points is moved to the right 5 and then up 4, and then that's your final resting spot, which this resides in quadrant 1. All right, so that is how you go through and apply a sequence of transformations for section 3.1. This is how you go through and make predictions, and this is how you go through and use coordinate notation to apply a sequence of transformations for points to get an end result of your image. So that is your notes for section 3.1, sequence of transformations. That is all that I have for you guys today. So thank you guys for listening. If you have any questions, be sure to let me know or shoot me an email. And that is all for today. So thank you for listening, and I hope you have a great day. All right, bye.